Mr. Kazi here with another chemistry lesson, and today's lesson is going to be on the SI, metric, and CGS systems. Measurements are very important to the scientist because so much of our work or data is dealing with measurements and quantitative units, so we need to understand the measuring system that scientists use. Most scientific data comes from measurements, so a standard is needed for all scientists. And a standard keeps data accurate, precise, reproducible, and unchanging. Scientists need to be able to reproduce the data of other scientists, and so having a standard makes this easy and convenient. Three systems that we will be using are the metric system, the SI system, and the CGS systems. Beginning with the metric system, it was introduced in 1791 during the French Revolution, probably really the only good thing that came out of the French Revolution. It was not developed originally as a scientific tool, but just as part of the revolution in trying to supposedly get everything to go along with reason. But in 1875, it was adopted as a scientific standard, and this made sense because of its being based on the powers of 10. And being based on the powers of 10 made it fit right in with our counting and the way we count, and right in with the way we do numbers. Our whole number system is based on powers of 10. That's why we call it the decimal system. In reality, the metric system just is a natural fit for the scientific world. The units in the metric system: for length, we have the meter. Mass, we have the gram. Volume, we have the liter. Time is the second, and temperature is Celsius. The Système International system was developed in the 60s. Came up with 7 fundamental units, and then all the other units that come out of the SI system are derived units. The derived units and the fundamentals are still part of the metric system. The top 4, length, mass, time, and temperature, and then we had electric current, luminosity, and the amount of substance. The top 4 are very important to us as chemists at this level, and at the end of the year we're going to be talking about the amount of substance. But other than these 7, anything else is considered a derived unit. So what are the 7 fundamental units? Well, length is the meter, mass is the kilogram, time is the second, temperature is Kelvin, then we have electric current, which is the ampere or amp, and then we have luminous intensity, and that's the candela, and then the amount of a substance, which is mole. And you want to know these 7 for tests and quizzes? And remember that the top 4 are the ones that we will be using the most. All the other units that come out of the SI system are considered derived units. And derived units are created from the fundamental units. So for something such as volume, it would be meter times meter times meter, which is length times width times height, which is the meter cubed. And a cubic meter is actually pretty big. It'd be more like a bathtub than something that we would be using in the chemistry lab for a beaker. So we have the CGS system, and the CGS system is just a little bit smaller and a little bit more useful in the laboratory, but it's still part of the metric system. And we have the centimeter, and we have the gram, and we have seconds. And these are just a bit more lab friendly. And so that'll be what we're using in the lab a lot. Now, a really cool thing about the metric system is that it's based on tens, and there are a set of prefixes that help us understand the units. So we have to learn some prefixes, and the large prefixes are as such. We have tera, which means 1 trillion, giga, which means 1 billion, mega, which means 1 million, and kilo, which is now kilo is the most important one here for us. The small prefixes are deci, which means 1/10, centi, which means 1/100th, 1,000th is milli, 1/1,000,000th is micro, and 1/1,000,000,000th is nano. And notice that since M is already used for milli, micro uses the Greek letter mu in its abbreviation. So be sure you note that difference in the units. And also notice that we have decimal equivalents and fractional equivalents for each of these small prefixes. The two most important will be centi and milli. Our most common units are going to be gram, liter, and meter. And in the laboratory, of course, we're going to be using Celsius for our temperature. So those are our most common units. And then, of course, our most common prefixes are going to be kilo, centi, and milli. Most common measurements that we're going to see in the laboratory: kilogram, milligram, milliliter, centimeter, and millimeter. I'd like to add on it, we're going to use grams a lot also, and I probably didn't put that on here because it's a base unit, but grams, liters, and meters in themselves will be used quite a bit with these variations that we use in the laboratory. If you have any questions, send an email to Mr. Kazi at mrkazi.com, and be sure to go to mrkazi.com for PowerPoint videos and much, much more. And subscribe to my YouTube channel. The studies have shown it increases your IQ. If you have any problems or questions, send me an email, and maybe it'll make the problem of the week. Thanks a lot. Happy ions.